Okay, this is a continuation of the hashing video. This is double hashing. The last one was hashing with linear probing. But we're going to start as though you didn't even watch that, because maybe you didn't. So double hashing has two hash functions, a primary and a secondary. The primary, what it means is where to go. That is where you want to put it in the hash table. The secondary says where to go if full. Like, I can't go there. Yeah, that spot's already taken. Where should I go next? Where to go next? So we need to just calculate all these values, and they're not very hard once you know what you're doing. It's just a bunch of math, but let's get started. The primary we're going to do first, then the secondary we're going to do separate. It helps to just make a table, but that's what this table will be. And our answers will go down at the bottom. That's going to be our modulus table, and this is going to be our actual answer, our hash table down here. So to get modulus by hand, I find I do this. I just put the multiples of, we're doing primary, so the multiples of 13. 13, 26, 39, up until it's beyond the values that we need. So then to find the modulus of any of these numbers, what we do is just find the multiple that is closest to but less than, and then subtract that value from this value. For example, 98 mod 13. Come to the 13 multiple table. 91 is the value that's closest to it, but less than 98. So 98 minus 91 is 7. 33, the value that's closest to but not greater than, is 26. So 33 minus 26 is 7. 36. 26 is the value closest to but less than. So 33 minus 26 is 10. 96, we have 91. 96 minus 91 is 5. 77, what do we have? 65. 77 minus 65 is 12. 11 is less than 13, so it'd be minus 0, so it'd just be 11. 27 is 26. 27 minus 26 is 1. 84, the value less than but closest to, is 78, so 6. 66, the value closest to is 65. 66 minus 65 is 1. 58 is 52, so that's 6. So these are our values of k mod 13. The next one is 1 minus k mod 7. So what we're going to do is just k mod 7 first, and then we'll do the 1 minus that next. So we're going to be careful because we don't want those to be considered our answers. So we're going to put them down here. So mod 7, we're going to go ahead and get rid of all these 13s, multiples of 13, and replace them with 7s. 7, 14, 21, 28. I have to go pretty far with this. 98 should be enough. Okay. So then we're going to go with 98 mod. We'll even put this 1 minus. No, we'll just do the k mod 7 first. So 98 is 98, so that means it's 0. K mod 7 is 0. 33, 28 is lower. So 33 minus 28 is 5. 36, 35 is 1. 96, 91 is lower is 5. what do we have? 77 is a multiple, so it's 0. 11 is 7. 11 minus 7 is 4. 27. 21. 27 minus 21 is 6. 84 is a multiple, so 0. 66 is 63. 66 minus 63 is 3. And 58 is 56. 58 minus 56 is 2. Now we don't want to forget, we don't want k mod 7, we want 1 minus k mod 7 to be our secondary function. So 1 minus, no, 7. 7 minus k mod 7 is our secondary function. And the reason we do this is because the secondary function can't map to 0. Sorry about that. So it's going to be whatever the mod is, that number minus the k mod, whatever. So we're going to take this from 7. So 7 minus 0 is 7. 7 minus 5 is 2. 7 minus 1 is 6. 7 minus 5 is 2. 7 minus 0 is 7. 7 minus 4 is 3. 7 minus 6 is 1. 7 minus 0 is 7. 7 minus 3 is 4. 7 minus 2 is 5. And these are the numbers that we want in the secondary, our secondary keys. Now we're going to walk one by one through them and try to place them. First, we're going to place 98. We're going to attempt to put it in its primary hash, and it's available, so we will put it there. Second, we're going to put 33 in its spot. Now, 33's spot is 7, but it's taken. And this is the difference between linear probing and double hashing, because with linear probing we would just put it in the next spot. But with double hashing, we'll resort to this number to determine how many spots we will advance until we put it in the spot that we find. So we're going to go 2. So 7, 1, 2 is 33. So we're going to put 33 in the 9 spot. And that's the point of double hashing, which hopefully we'll encounter a few more times so that you can see it in action. Also, we're going to need to jump to 0 when we get too far, but we'll get there. 36 goes to 10. 10 is available, so 36. 96 goes to 5. 5 is available. 96. 77 goes to 12, which is available, so 77. 11 goes to 11, which is available. 27 goes to 1, which is open and available. 84 goes to 6, which is available. 84. 66 goes to 1. 66 goes to 1, but 1 is not available, so then we have to ask what's 66 secondary key. It's 4, so we have to advance 4 spots. 1, 2, 3, 4. 66 goes here, but that's taken, so we advance 4 spots. 1, 2, 3, 4. That's taken. So we have to go 4. 1, 2, 3, and then back to 0 for 4. So 66 goes to 0. And that's what double hashing is. And then one more. 58 goes to 6. 58 goes to 6. So 6 is taken. So we have to determine 5. We're going to go 5 at a time. 1, 2, 3, 4, 5. Nope, 11's taken. 1, 2, 3, 4, 5. 3 is good, so 58 goes to 3. And we don't need to get into the details, but 7 and 13 are relatively prime to each other, so their greatest common denominator is 1. which means that you wouldn't end up in a case where it would miss spots. It will always eventually end up going to every spot. But that's a side note. This is how you do this is the final answer for the double hashing. And again, what you do, you find the primary mod, you make a chart for that. You find the secondary mod. Make sure that you use, because it's usually 7 minus or whatever, k minus k, something minus k mod something. So make sure you're not doing just that mod, but rather the minus, the like complement of it. And then you chart that, and then you start mapping. You go try it to go to the preliminary. If it's already taken, you see what its secondary advanced thing is, and then you just keep bouncing around until you get where it goes. If you have any questions, let me know. Hopefully that puts some insight into it.